Hi, good day everyone. This video is about solving rational inequality. Again, a rational inequality is composed of rational expressions combined with different inequality symbols or sign. So to solve for the rational inequality, we have here just given steps. Number 1, we need to write the inequality with a single rational expression on the left-hand side of the inequality and 0 on the right-hand side of the inequality. Number 2, determine the meaningful numbers by setting the numerator equal to 0 and setting the denominator equal to 0. Next is to use the meaningful numbers to separate the number line into set of intervals. And last, we need to test for the meaningful numbers. So let's say we have this given inequality. So let's try to solve this one. Let's say we have x plus 2 over x minus 3. That is less than or equal to 0. Okay, so again, step number 1 is we need to make sure we have this single term left hand side and 0 as our right hand side of our inequality. So that means for step number 1 we're already done, and let's proceed to step number 2. So for step number 2, we need to determine the meaningful numbers. Okay, so we need to separate our numerator to our denominator, and let's equate them to 0. So we have for numerator, so we have x plus 2 is equal to 0, and we have this another value for the denominator, which is x minus 3 equal to 0. And let's solve for their values. So if we have x plus 2 is equal to 0, so just solve for the values of x. So we need to subtract 2 both sides. So we have minus 2 and minus 2. Therefore, the first value of x for the numerator is x equals to negative 2. Next, for the denominator, since we're looking for the value of x, we need to add 3 both sides. Or that is what we called as the APE. And the value is positive 3. Okay, so we have this meaningful number from numerator, which is negative 2, and 1 for the denominator, which is positive 3. Now, let's try to test if the given values are part of our solution or not. So let's use our original function or inequality to double check our given meaningful numbers. So therefore we have x plus 2 over x minus 3. We have less than or equal to 0. And let's test first for the value of our numerator. Okay, so therefore that is negative 2 as x. So we have negative 2 plus 2 over negative 2 minus 3 is less than or equal to 0. So just simplify. So we have negative 2 plus 2. That is actually equals to 0. So 0 over negative 2 minus 3, that is negative 5. And that is less than or equal to 0. So according to the rule of fraction, if our numerator is equal to 0, automatically that given expression is equal to 0. So that means we have 0 is less than or equal to 0, which is automatically true. So we have this numerator, its meaningful number is part of our solution. Next, let's try to use our denominator. So what will be the value of our function if we have 3 as the value of x? So therefore we have, let's erase this one, and then we have positive 3 and another 3 for the values of x. Therefore it will give us 3 plus 2, which is 5, over 3 minus 3, which is 0, and that is less than or equal to 0. So now let's try to test. According to the rule of fraction again, if the denominator is equal to 0, automatically the entire value of that fraction or expression is equal to undefined. So that means if that is undefined, automatically this given relation is a false statement. So therefore, the meaningful number for the denominator is not part of our solution. Okay, that is our step number 2. Now, let's proceed to step number 3. So use the meaningful numbers to separate the number line into intervals. So that means we need to construct a number line, and let's plot those meaningful numbers. So approximately, let's say we have this given value for negative 2, and we have this value for positive 3. Okay, so the tip here is, if the given value or the meaningful number is part of our solution, therefore we need to use a solid line or solid dot to plot those points. Therefore, since negative 2 is part of our solution, we need to use a solid line or a solid circle. And if that value is not part of our solution, so since that value will set as intervals lang, so we need to construct a hollow circle. Okay, so according to our number line, we have this created interval. So we have this interval A, B, and C. So that is our step number 3. So let's proceed to step number 4. So for step number 4, we need to test the meaningful numbers. If they make the inequality true, then they're part of our solution. If false, they're not part of our solution, which is actually similar to our testing here. So we test the meaningful numbers, and next, let's test any value to our intervals. Okay, so let's say for interval letter A, so we have this given set of values for letter A. So let's try to pick any value under that interval. So let's say let's try to use -4 or -3. Okay, and then next for interval letter B, let's try to pick any number or value. So we have this interval letter B. So I think let's try to use 0 for this interval. And then for interval letter C, we have this given set of values. I think let's try to use +4. So after that, dear students, let's test each values. So that means if we have this true statement, if we have true, therefore that interval is part of our solution. If false, they're not part of our solution. So let's try to test interval letter A. So for interval letter A, we have x plus 2 over x minus 3, which is less than or equal to 0. And let's substitute the given value. So for A, it will give us -3 plus 2 over -3 minus 3 is less than or equal to 0. So that means we have -3 plus 2, that is actually -1, over -3 minus 3, that is equals to -6. So therefore, this is actually equals to 1 over 6. And let's test. So 1 over 6 is less than or equal to 0. So again, that is false. Okay? So because 1 over 6 is actually greater than 0. So that means interval letter A is not part of our solution. Okay? So let's try to test interval letter B. So for letter B, just replace the values of x as 0, and let's try to test if it is true or false. So we have B as 0, so we have 0 and 0, so it will give us 0 plus 2, that is equals to 2, over 0 minus 3, that is equals to -3. And that is less than or equal to 0. Now, let's try to test. Is -2 over 3 is less than or equal to 0? So that is actually true. Okay? That means we have this interval letter B as part of our solution. Next is, let's try to test interval letter C. So for letter C, just replace the values of x as +4, and let's try to test. So it will give us 4 and 4. So we have 4 plus 2, that is equals to 6, over 4 minus 3, that is equals to 1. So obviously that is equals to 6 is less than or equal to 0, and that is a false statement. Okay? That means, according to our test, we have this interval letter B as part of our solution. So for step number 5, just write the interval relation or the answer for this given problem. So for step number 5, again, just express the answer into interval notation. So that means if letter B or interval letter B is part of our solution, if you want to use this line or number line to represent your answer, just shade this given part. That means we have this interval letter B as part of our solution. Okay? If you want to write your answer or express it into an interval notation, that means we have this um, value of negative 2 as part of our solution up to 3. That is our final answer. Okay? So let's proceed to step number or example number 2. So for example number 2, let's say we have this 2x minus 5 all over x minus 5, and that is less than or equal to positive 3. Okay? Let's try to test what will be the possible values of x. Okay? So for step number 1 again, we need to double check or make sure that we have this left hand side as a single term and right hand side of the inequality as 0. So obviously we have this right hand side as 3. So we need to change this one. We need to put 0 sa ating right side. So that means we need to move this value. So it will give us subtract 3 both sides. Therefore, we have 2x minus 5 over x minus 5 minus 3 is less than or equal to 0. Okay? So, after that, dear students, we need to express this one as a single term. Okay? So, we have 2x minus 5 all over x minus 5 minus 3. Okay? So, we need to simplify this given expression. So, that means to simplify this, just solve for its LCD. Okay? And other subtract the given expression. So that means we have this given LCD as x minus 5. Okay? And we have x minus 5 divided by x minus 5. That is 1. 1 times 2x minus 5, the answer is 2x minus 5. Okay? And do the same thing sa ating next term. So we have negative x minus 5 times or divided by 1. So we have here this invisible 1 as the denominator of this or negative 3. So we have x minus 5 divided by 1. That is x minus 5. And x minus 5 times negative 3. So therefore, it will give us negative 3 times x minus 5. And that is less than or equal to 0. Okay? And then after that, just simplify. So let's distribute the value of negative 3. So multiply to x and to negative 5. So therefore, it will give us 2x minus 5. Negative 3 times x, we have negative 3x. And negative 3 times negative 5, that is positive 15 all over x minus 5. And that is less than or equal to 0. So after that, just combine the like terms if we have like terms or common terms. So we have 2x and negative 3x, and we also have these constant terms as negative 5 and positive 15. Okay? So just combine those values. So we have 2x minus 3x, that is negative x. We have negative 5 plus 15, that is positive 10 all over x minus 5. And that is less than or equal to 0. And let's try to double check. If we have this inequality as single left hand side and right hand side as 0. So that means we need to proceed to step number 2 after this given expression. Okay? So let's proceed to step number 2 again. So just determine the meaningful numbers by setting our numerator and denominator equal to 0. So that means for numerator, we have negative x plus 10 is equal to 0. And for the denominator, it will give us x minus 5 is equal to 0. And let's solve for the given values. Now, for the numerator, if negative x plus 10 is equal to 0, that means we need to subtract 10 both sides. Okay, it will give us negative x is equals to negative 10. And let's try to remove this negative sign. Okay, let's multiply both sides to negative. That means we have this first value of x as positive 10. Okay, next. For the denominator, we have x minus 5 is equal to 0. So just add 5 both sides and simplify. So therefore, we have x as positive 5. Okay, so we have this set of meaningful numbers. Now, let's try to test our meaningful numbers. Same with our step number 4. Test the meaningful numbers if they make the inequality true or false. So if that is true, they're part of our solution. If false, they're not part of our solution. Okay, let's try to double check our given meaningful numbers. So for the numerator, so we have this x as 10. So try to use our given expression. So we have negative x plus 10 all over x minus 5 is less than or equal to 0. So if x is 10, therefore it will give us negative 10 plus 10 all over 10 minus 5. And let's simplify. So negative 10 plus 10 is actually equal to 0. All over 10 minus 5 is 5. And that is less than or equal to 0. And again, any fraction with the numerator as 0, that means the entire fraction is equal to 0. So obviously 0 is less than or equal to 0. And this is true. So let's put letter T. Okay. So next, let's try to use our denominator, wherein we have x as 5. So if x is equal to 5, therefore it will give us negative 5 plus 10 all over 5 minus 5. So let's simplify. Negative 5 plus 10 is equals to 5 all over 5 minus 5, that is equal to 0. Okay, but let's recall our given concept. If our denominator is equal to 0, that means the entire fraction is undefined. So obviously this is a false statement or false relation. So that means we have letter F. So we have this meaningful number from the numerator as part of our solution, and we have this denominator as not part of our solution. So let's proceed to step number 3. So for step number 3, we need to use the meaningful numbers to separate the line or the number line. Okay, so it will give us the set of intervals. So that means let's construct a number line. Okay, and let's plot those values. So we have this meaningful numbers as 10 and positive 5. So approximately we have 5, and let's say we have 10. Okay, and again, according to our test, we have 10 as part of our solution. Therefore, we need to use a solid circle for this one. And we have 5 as not part of our solution. Therefore, that value will just set the interval. So let's try to use a hollow circle. Okay. So again, it will give us this set of interval. So it will give us interval A, interval B, and interval C. Okay. So after that, your students just pick any value under those intervals. So let's say we have for interval A. So since interval A is under this part, so let's try to use 0 for this one. For interval B, okay, so for interval B, we have this given values. Okay, and try to pick any value under that interval. So let's try to use positive 6. Same with interval C. So we have this set of interval, letter C, that is 10 up to positive infinity. Let's try to use 11. Okay, so again, same procedure, just test all of those values. And those values will determine if that interval is part of our solution. So let's use our original expression or our modified expression. So let's try to use negative x plus 10 all over x minus 5. And that is less than or equal to 0. Okay, if the value of x is equal to 0, let's try to use our first interval as 0. So that means it will give us negative 0 plus 10 all over 0 minus 5. So just simplify. If this is less than or equal to 0, so that means if we have this given expression negative 0 plus 0, that is 10 all over 0 minus 5, that is negative 5. Okay, and this is less than or equal to 0. So for the first interval, we have this 10 over negative 5, that is equals to negative 2. Okay, negative 2 is less than or equal to 0. That is obviously true. Okay, therefore, interval A is part of our solution. Okay, next, let's try to test interval letter B. Let's try to use 6, okay, as our value of x. So if we have 6 as the value of x, therefore it will give us negative 6 plus 10 all over 6 minus 5. And that is less than or equal to 0. And let's simplify. Negative 6 plus 10 is actually equals to positive 4 all over 6 minus 5, that is equals to 1. So 4 over 1 is not less than or equal to 0. That means for the interval letter B, we have this expression that is not part of our solution. So it is false. Okay? So B is not part of our solution. And let's try to use our last interval, which is C. We have C as 11. Okay? If the value of x is 11, therefore it will give us negative 11 plus 10 all over 11 minus 5, and that is less than or equal to 0. So let's try to check, and let's simplify. So negative 11 plus 10 is negative 1 all over 11 minus 5, that is 6. And this is actually less than or equal to 0. Okay, we have a negative value, so that means this is true. And interval letter C, that means interval letter C is also part of our solution. Okay, so therefore, if we want to plot this given set of values to our number line, so if we have A as part of our solution, therefore we need to shade this part. B is not part of our solution, so let's skip that interval. And letter C is also part of our solution. So again, let's shade this one. So for the number line, or for the representation of our solution, we have this given number line. And if you want to write or express your answer in interval notation, that means we have this given value as this. So we have this 5, okay, from 5 up to negative infinity, and we have this 10 up to positive infinity, and that 10 is part of our solution, right? So that means we have this interval notation as negative infinity up to 5, okay, union 10. Okay, so again 10 is part of our solution. Let's try to use this bracket. So we have 10 up to positive infinity, and that is our final answer. Okay, so thank you everyone, and God bless.